In this video, I'm going to talk about glycolysis. Glycolysis. Many students are finding this aspect of biology difficult, and as a result of this, I need to give adequate explanation on how you will have understanding of glycolysis. All right. We are not going to define it until we really understand it. Glycolysis occurs in the cytosol of a cell. Glycolysis, it occurs in the cytosol of a cell. Full stop. And of course, it is the first stage of aerobic respiration. It is the first stage of aerobic respiration. It is the first stage of aerobic respiration. All right. Now, glycolysis itself has several stages. Glycolysis itself has several stages. Glycolysis itself has several stages. So, glycolysis has the following stages. Number one, that is phosphorylation. Phosphorylation, that is number one. Number two, that is rearrangement of glucose 6 phosphates. Number three, substrate level phosphorylation. Number four, lysis of fructose 1,6 biphosphates. Four is another substrate level phosphorylation. Then 6, we have dehydrogenation. So, for you to understand glycolysis very well, you must have the understanding of the basic stages of glycolysis. So let's start taking them one after the other. Number one, that is phosphorylation. Phosphorylation simply means addition of phosphate group addition of phosphate group to another compound. So when glucose reacts with ATP, the product is glucose 6 phosphates plus ADP. Glucose 6 phosphates plus ADP, and that is what is called phosphorylation. Phosphate group has been added to glucose, turning glucose to glucose 6 phosphates, then plus ADP. When phosphate is released by ATP, we have ADP. Alright? Now, what then happens after that is the arrangement of this. Glucose 6 phosphates is rearranged to give us fructose 6 phosphates. That is the rearrangement reaction. Then after that, we have, I shouldn't have called these substrates. We can still call it phosphorylation alone. Sorry for that. So, the next one is another phosphorylation. Fructose 6 phosphates. Fructose 6 phosphates can then take up another ATP to give fructose 1,6 biphosphates plus ADP again, plus ADP. Then the next thing is that lysis of fructose 1,6 biphosphates. Lysis of fructose 1,6 biphosphates. 1,6 biphosphates we split to give us 2G3P. 2G3P. 2G3P simply means glyceraldehyde 3 phosphates. Glyceraldehyde 3 phosphates. So fructose 1,6 phosphate will break up into 2 to give us glyceraldehyde 3 phosphates. This one has 6 carbon atoms. This one has 3 carbon atoms in 2 places. And that is just that. Alright. Okay. The next step is that ADP now. ADP, and that is substrate level phosphorylation. ADP will take up inorganic phosphates from G3P to give us ATP. But 4 ATP is usually produced in glycolysis. So I will balance my reaction by having 4 ADP, 4 inorganic phosphates. And this one is called substrate level phosphorylation. Substrate level phosphorylation. Alright? Now, there is an electron carrier. There is an electron carrier called NAD ion. NAD ion. When NAD ion take up hydrogen, we call it dehydrogenation. So this will be plus H2 to give NADH plus hydrogen ion. This is an oxidized form and this is a reduced form. Usually this is 2, 2, to 2. All right. So the major purpose of glycolysis is to produce 4-ATP and the NADH. All right. Before I stop this video, let us have a recap. All right. Glucose is a stable compound. So we need to make it unstable. By doing so, we have to add ATP. And glucose will take up inorganic phosphate from ATP to give us glucose 6-phosphate. Plus ADP. Glucose 6-phosphate will then rearrange itself to give us fructose 6-phosphate. Glucose 6-phosphate and fructose 6-phosphate are isomers. We only need rearrangement to form this. This is less stable compared to glucose. Fructose 6-phosphate then take up ATP again in another type of phosphorylation. To give fructose 1,6-biphosphate plus ADP. So fructose 1,6-biphosphate will break into 2, and that is lysis to give us 2G3P. So we have ADP taking up inorganic phosphate from another compound. When ADP take a inorganic phosphate from another compound, we say that we have what is called substrate level phosphorylation, and we get 4-ATP. Nadione is an electron carrier. Nicotinamide adenine diphosphate. Adenine diphosphate. We react with hydrogen to give us NADH plus hydrogen ion. All right. So in all, glycolysis produces 4-ATP, but produces only 2 net ATP. Why? Because 2 ATP has already been consumed. When we subtract these 2 ATP from 4-ATP, the net ATP produced by glycolysis is 2 ATP. Thank you for watching my video. This video is directly from Tutopedia Tutorial Center. We are located at Agbo, very close to University of Ibadan. You can call us on this number 070 50 68 1854. Thank you for watching the video.